In today's class, we will start with our first lesson called matter. We will study about three things. First is kinetic theory of matter. Second, three states of matter. Third, change of state. Before we move on to our first topic, we will enrich ourselves with the new vocabularies. Kinetic energy. Kinetic energy is the energy in motion or the energy of a moving object. So here, a man is running. He is possessing some kinetic energy when he is running. Right? What is matter? Any physical substance which occupies space and possesses some rest mass is called matter. So here are the examples for matter. Anything, any material which you see which occupies space are called as matter. What is theory? A supposition or a system of ideas intended to explain something. Are you an example for the matter? Yes, definitely. All the human beings or any materials which we see daily are the examples for the matter. When you move, what energy do you possess? We possess kinetic energy when we move. So, we will jump into our first topic called kinetic theory of matter. We know what matter is, but what does the matter made up of? What is this? This is a chalk piece. When I break this chalk piece, what will I get? I will get two pieces of chalk piece, right? When I further crush it, what will I get? I will get a chalk powder. Is it possible for us to break this fine powder particles further? You might answer no, but it is possible for us to break this fine powder particles into finer particles. When I divide the fine powder particles, at last I can get atoms. It is not possible for us to do this process by our hand, but some great instruments can do this process very easily. And we can also visualize these finer particles using those instruments. Now we have found that matter is made up of smaller particles called atoms. Do the atoms remain stationary or in motion? When we see the matter as a whole, we will say that the matter remains stationary. The atoms which makes the matter don't remain stationary, they are in constant motion. The atoms vibrate at their own position in all the directions. So, the atoms don't remain stationary, but they are in constant motion. So, the two assumptions of kinetic theory of matter are: matter is made up of small particles called atoms or molecules. The particles are in constant motion. We already know that anything in motion has kinetic energy. So, the matter also possesses kinetic energy because atoms presenting in it are constantly moving. How much kinetic energy does the matter possess? For that, we need to explore the arrangement of atoms in three states of matter. What are the three states of matter? Solid state, liquid state, and gaseous state. So, shall we explore the arrangement of atom in these three states? In solid state, example ice, the atoms are tightly packed. In liquid state, example water, the atoms are loosely packed. In gaseous state, example water vapor, the atoms are very loosely packed. So you can see the arrangement of atoms now: solid state, liquid state, and gaseous state. You can notice here that in solid state, the atoms don't have enough space to move, but in liquid state, they have some space to move. In gaseous state, there is more space in between each of the atoms to move. You can now guess of the kinetic energy of each of these matter. How much kinetic energy does each state possess? In solid state, the atoms don't have enough space to move. Definitely their kinetic energy will be low. But here, in liquid state, they have some space to move, therefore their kinetic energy will be high. What about the gaseous state? You can guess easily now. Kinetic energy in gaseous state is very high. We have now noticed how much kinetic energy each state possesses. In solid state, kinetic energy is low, in liquid state it is high, and gaseous state it is very high. This energy is related to temperature. We have applying heat energy increases the kinetic energy of the particles. The particles become more energetic, and in turn it results in rise in temperature. This is the simple experiment to show the kinetic theory of matter. Let us watch. Now the ink is being dropped into the water. We can see that the ink is getting diffused through the entire volume of water, right? Now think, why it is happening? Is this diffusion possible if the particles are not in constant motion? No, right? So this proves that the particles are constantly moving. Now we will see the PhET simulation available in the internet to explore our kinetic theory of matter. So here you can see the atoms and molecules options. I have chosen water molecules, right? Uh, Water molecules consist of hydrogen and oxygen atoms. Here we can increase the temperature or decrease the temperature. The temperature is being displayed here. Now I have chosen the solid state. You can see that in solid state, the molecules take up some definite arrangement and they are not moving very much. Since they are not moving very much, their kinetic energy is very low. Now I am going to choose a liquid state. When I choose the liquid state, the atoms are not arranged in a definite manner and their kinetic energy is more in liquid state than in solid state, right? Now I'm going to choose gaseous state. When I choose gaseous state, the kinetic energy is even more. We can notice that. The molecules move far away from each other. They can move very easily. I'm going to choose the liquid state. When we supply heat energy, we can see that the kinetic energy increases and the molecules move far away from each other. Now I'm going to decrease the temperature. That is, I'm going to cool it. When I cool it, what is happening? The kinetic energy of molecule decreases. As a follow-up work, you should try out the PhET simulation for other atoms and molecules also. You have to observe the changes and write down your observation in your notebook. Thank you.